Hello, thank you. We thought I'd stand here for a moment to get a photograph for the Royal Society archive. Do you mind? Don't wave, though. I think you should probably just look as though you're interested and intellectual. And how's that? Oh, keep looking interested. Now you can wave if you want. Hello. Is that good? All right. Thank you for that. So thank you for joining us at this, which is the final event of the Royal Society's You and AI series. And I want to welcome everyone here tonight at the Barbican and the people watching online. So thank you for joining us. I'm Professor Brian Cox, the Royal Society's Professor for Public Engagement in Science. Now, you have to go back to, in fact, we found in research, Homer's Iliad in 800 BCE to find the first accounts of automata. And over the centuries, those ideas have developed into the more familiar ideas of robots, cybernetics, and now artificial intelligence. And it was Royal Society fellow Alan Turing who began to grapple with the notion specifically of a machine-based intelligence throughout the 1940s. And in the 1950s, he posed the question which has become known now as the Turing test, which is, can machines think? And the idea is that a machine could be understood or presumed to think if it exhibits an intelligence which a human might think was actually human. And in reality, this is something we'll discuss tonight, that might be considered to just point to the idea that humans are gullible, rather than a measure or a perception of machine intelligence, if you like. But perhaps this tells us that our relationship with AI might be just as important as the relative intelligence of the machine itself. As the use of artificial intelligence grows and spreads throughout society, how do we feel about it making decisions on our behalf and doing jobs for us? Well, last year, the Royal Society launched a landmark report on machine learning, the technology that drives many of the current advances in artificial intelligence. And since then, the Society has been supporting a well-informed public debate. It's a bold idea, isn't it? A well-informed public debate. Could use that in many other fields, I think, about the development of AI in order to help create a society in which the benefits of AI are shared equally. Now, with me this evening are some of the world's leading thinkers on AI, and together we'll be discussing AI's potential to revolutionize fields like healthcare and education, but also the challenges and issues surrounding the ethics of mass use of the public's, that is our, data. Now, before I introduce the panel, I'd like to thank DeepMind, who've kindly supported this whole You and AI series. But now, without further ado, could you please welcome our panel? So by way of introduction, Professor Suchi Saria is the John C. Malone Assistant Professor at Johns Hopkins University, Department of Computer Science. Professor Peter Donnelly, FMedSci and FRS, is Professor of Statistical Science at the University of Oxford and CEO of Genomics PLC. And Dr. Vivian Ming is a theoretical neuroscientist, technologist, entrepreneur, and co-founder of SOCOS. Now, the first question, before we really start, I think, is to ask each of the panel for a definition. AI has captured, I think, many of our imaginations, perhaps our nightmares in some sense, but it does mean different things to different people. So perhaps if I could ask each of you, first of all, to define what AI is.
Oh, go, okay. Artificial intelligence, I think, can go by a variety of definitions. One of the dullest, but perhaps most accurate, is it's any autonomous system that can make decisions under uncertainty. So if there's a problem that has no right answer, and there's no human there to make a decision, an AI would be a system which could do that. There's no right chess move. There's no correct answer to how fast should I take this right turn in my car, or should I give this person a loan or not? They're just fundamentally uncertain decisions. I actually like something a little more practical when I describe AI, particularly because I do a lot of work in what's called the future of work. And to me, then, AI is, particularly modern AI, is any brief expert human judgment. Read a contract, decide whether to hire someone, is there a mass on this x-ray, made increasingly faster, cheaper, and often better than a human can make it.
I think Vivian's totally nailed it. I don't have a lot to add, except to mention a specific form of AI and one of the developments that's driving lots of the things that impact on our lives now, and that's something called machine learning. So that's a form of AI, and it's the idea of computer systems that can learn for themselves from examples and data and experience. The idea that instead of, as in the old days, programming a computer to tell it what to do in every eventuality, in machine learning, you program a computer so that it can study the examples and it can learn for itself what the patterns are to help it make the sorts of decisions that Vivian was talking about.
I think they've mostly captured most of the essence of what AI is, just sort of a little bit of historical context, which is AI as a field emerged in the 60s, where it was primarily the ambition of researchers from a diverse group of fields, all the way from physics and cognitive science to computer science, if you will, engineering, where the goal was to build computers that could behave intelligently the way humans did. And now one might argue, well, do humans behave intelligently? And so essentially you can see the goal was ambiguous, and over the course of the last 50 years or 60 years, we've worked hard to determine what intelligence is. What is human intelligence? How should we build machines that are intelligent? And should we be mimicking humans, or should we be determining what is the right thing to do in a given situation? And that's sort of the field as a whole.
You know, and it's worth noting that many of the things we really thought of as being the exemplars of intelligence, like can you do a math proof, or can you play chess, were in fact some of the very first Newell and Simon invented programs back in the very early 60s that could do these things. Whereas, are any of you in the front row smiling turned out to be an enormously difficult problem to solve for a very long time. Although now it turns out we can throw it onto your phone as a free app. But it turns out it's a much more complex problem than we originally appreciated it to be.
Not just because we can't see them, because of the lights.
Yes, the glaring lights, although the ones up front are clearly waiting to get their money value for this performance.
You've all described, I think in a sense, what we might call general AIs, which is something that's very human-like and multi-purpose. But I suppose there are also AI systems or machine learning systems that have very specific tasks. So would you like to comment on the difference between those two?
Am I going to do this again? All right. So there are these two big concepts in a lot of modern AI discussions. One is called artificial general intelligence. This is something that kind of thinks like we do. It really understands and navigates through the world. And I'm going to contend no such system like that exists in the world today. No one is on the verge of inventing it. However, these systems that can take a very targeted approach to understanding the world. For example, is anyone in the front row smiling? Is there a loophole in this legal contract? Is there a giraffe in this picture? Building very targeted systems like that have been exactly where these systems have been so effective. But I would contend that the one that can recognize giraffes understands nothing about giraffes. It has no giraffe concept. And when you look at the mistakes made between people looking at photographs and kind of looking at ambiguous photographs to make a decision, is there a giraffe here or not? You can understand why they might be wrong. Maybe this is a llama with a head cold or something. Whereas when these AIs make these errors, frequently it looks nothing like a giraffe. Or it thinks something that looks exactly like a giraffe is not. And you come to appreciate we're really making decisions in pronouncedly different ways. So I would contend that these very simple systems that are really the core of AI today are approaching problems in a dramatically different way than all of us are.
Does that mean that the word intelligence is It's a complicated word, isn't it? I think there's a lot of baggage associated with it. When you say an intelligent system, I think a lot of people think of something like us rather than something that's good at a specific thing.
I think, you know, from having traveled across, from India, moving to the US at the age of 17, I got to learn new things that I didn't get to see as a child. And I distinctly remember, so humor. Humor is an example of something where, it's very cultural and contextual. And something I find funny now, I might have not found it funny when I was 15 and lived in India. But I distinctly remember thinking of it as a problem where I was back solving. Somebody was saying something, people were laughing. I was trying to figure out what's going on. And then eventually I understood the context. So what I'm getting at is, I think one thing that's difficult about intelligence is almost any, this ability to reason through things, like solve a difficult math problem, or to be able to recognize giraffes from llamas, you can pretty much sit back and think of it in some deductive way or logical way in which you can, I think, train a computer to do it. Or even perhaps ask children and ask them how they're doing it, and they'll describe it in a way that you could get computers to do it. So I think this notion of what is human intelligence and what separates, what is that essence of human intelligence we're trying to capture, I think is an open question from my point of view. I don't know, what do you think?
No, I completely agree. And also just actually to pick up on both points and Brian's earlier question, in some sense, the reason we're having the discussion, I suspect, many reasons, but it's because of the advances in the machine learning, in particular, approaches to very specific tasks and problems. The sorts of things that we interact with on smartphones every day, the ability to speak into a phone, and I don't think it understands what we're saying, but it knows how to react to what we're saying. Recommender systems when we shop online, the ability to have friends tagged in photographs on Facebook or other apps. All those sorts of things are because of progress in these very specific tasks. Image recognition is one of them. And it's been, again, to look back over the history, for most of my academic career, for example, computer vision has been a very active field, but throughout the 80s, which sort of dates me from early in my career, through the 90s and even the early and much of the 2000s, computer systems were just not very good. They'd get a little bit better each year, but they were nowhere near as good as people. And then over the last 6 or 7 years, they went from being not very good at all at that specific task to now, in many tests, as good as or better than people. Whether that's spotting giraffes, whether it's looking for pathology in an X-ray of some kind, computer systems, because of machine learning, can now outperform people. And similarly with voice recognition, similarly with some translation tasks. So it's that massive progress over the last 5 or 6 or so years, which has meant that we interact with this stuff all the time, but we're interacting with it, as you said, Brian, in terms of the ability to do very specific things now remarkably well.
Okay, well, let's move on to your questions. So we've split them up into 3 sections, and the first one we've titled, Who Benefits from AI at the Moment? And the first question is from Anya, and the question is, who does the current system of AIs currently benefit the most? So who'd like to start?
I can lead this off every time. I'm a paid pompous jackass. So, I think one of the truths of almost all of technology is that at least initially, it always benefits the people that need it the least. The very nature, particularly I've done a lot of work in educational technology, and in fact applying artificial intelligence to education, and everyone that goes into this field does it because, let's be frank, we're out to save the world. We're out to save some little kid. Can we build a little AI tutor? Imagine that in every kid in every home around the world. And the simple truth is a company like that is successful because it's able to sell its product to a wealthy set of parents that want to get a few extra points on a standardized test, which will change nobody's life whatsoever. And so we build these things, and they tend to be adopted. And part of the heart of this is because when we build them, we don't actually understand people. Many of us understand a lot about machines, although there's so much more to learn. But how machines and people interact, what do people think is valuable? I will certainly say in the education world, if you've put an app in the App Store, you have solved nothing. because the people that truly need that help will never go there. They will never download that app. They'll never make use of it because they don't believe in their heart it will actually make a difference. So, when we look again and again, we see that this really more is a concentrating power. It inevitably increases inequality, at least in the near term. And AI in particular is interesting because it can substitute for human judgment, at least in specific tasks, and in particular, often highly trained professional human judgments. It itself is profoundly inequality increasing in ways that we've never been able to do before, because now, not to pick on someone who I don't think is a bad guy, but now Jeff Bezos can substitute his AIs for a whole load of people he would have had to have paid to make those judgments before. And that also has a big influence on inequality.
So you're essentially suggesting there's a subtext to this question, which is it's not necessarily benefiting the public at the moment. You're essentially taking a cynical view that many of them are just increasing corporate profits, essentially.
I wouldn't build this stuff if I didn't think it was worthwhile, and I hope we have a chance to talk about that sort of work, but I'll be really clear. Building something because you think it will do good in the world is dramatically different than actually doing good in the world. And we can build tremendously powerful systems. They're tools. They're not truly autonomous in the sense that they don't understand the world, but they're tremendously powerful tools. But if we simply think that a hammer, by its very existence, builds a house, then we really have lost an understanding of how the world works.
I think this partly has to do with the way funding is structured right now. So most of funding in this field right now comes through individual research grants, which means no single professor or single lab has enough grants to build anything of significant consequence. On the other hand, venture capital and private corporations have a fair amount of funding, but also the vision. They see the vision for how this can bring good to the world. But then, like Vivian said, the challenge is if you are going down that route, you have to have a sustainable business model, which means you're naturally heading off in a direction where in the beginning, you're going to cater to audiences where they're able to pay for it. I work a lot in healthcare, and I think one of the promising things I see in healthcare is because of the centralized nature of it, which means data are held in large enterprises, or here the NHS, for example. If we're able to take advantage of this data and identify ways to diagnose diseases earlier, treat patients in a more targeted way, that technology can really be distributed at scale and can benefit many. So I think I'm optimistic.
Well, I agree with both the previous comments. I suspect I'll say that many times this evening.
You're going to go you're first
position.
next time.
It's a kind of complex and layered question. Who benefits from these systems at the moment? There's a sense in which most of us benefit because they make our lives a bit easier through our smartphones and the systems we interact with there. There's a convenience. I mean, those of you who would be my age and have kids, they find it impossible to imagine how you ever managed to meet anybody in the days before you could use these systems to find out where you are and where they are and converge, but somehow or other we muddle through. So there's a sense in which our lives are more convenient at the moment because of these systems. I think there's a real sense, and I'm hugely positive about it, about the potential benefit in really important areas. Healthcare is one of them, and education is another one, and the people on each side of me are making a difference in both of those, where the possibility to improve so many aspects of our lives is real. And yet, I think Vivian's absolutely right that we need to think very hard as a society about how we want to play out. I think if we let this happen without intervening or worrying or stewarding it in any way, there's a very real danger that the short-term and medium-term consequences will be not to improve the world as we hope, but to increase inequality. And I think as society, we have a massive duty to be active and to work out how to steward this. We need to be stewards. We need to look ahead and think, here are different scenarios as to how this might play out. Which are the ones we as a society want to happen? And which ones are we less keen on? And how can we try and use the levers we have to drive things in the right direction? Because I think it's pretty clear, as Vivian said, if we don't do very much, then the impact in the short to medium term will be to increase inequality, to make lives better for the people who are already pretty well off and not to help the people who aren't and to make those gaps bigger, which I don't think we want, but we need to be active in working out.
And by increasing equality, you mean by the most obvious route, which is replacing low-skilled jobs? Is that essentially it, or is there more to it
Well,
than
I would be even more provocative. You can go read the lunch with the FTP I did that got very provocatively titled "The Professional Middle Class is About to Get Blindsided." Turns out it's not impossible to build a robot to pick strawberries or to drive cars, but it's actually very difficult and much more difficult than building a robot to do financial analysis or to read x-rays. So those latter things seem like very sophisticated jobs. We pay people an enormous amount of money to make those sorts of decisions, even though often those decisions are very rote. Well, if they're rote and economically valuable and people make them on a regular basis, you have just described a machine learning training set. And so it turns out it's a lot easier to build an AI to do those jobs than to build an AI to pick strawberries. Yeah. And it has interesting implications because in a lot of the discussions that I'm sure many of you have read about or heard on the radio, it's very much about what do we do with all of these low-skilled workers that will be put out of jobs, which is still a legitimate question. Even if AI is good, I grew up in Salinas, California, which is where John Steinbeck is from. So I grew up in the realm of the grapes of wrath and, you know, the devaluation of humanity out on the field 12 hours a day, and it still goes on every day, and it would be a human good for that to end. It would be good if we could build robots that could go out and collect all of this for us. And so it's still a legitimate question to say, what do we do with millions? This is the largest job vertical in the world is agriculture, and the next is transportation. But what do we do with a group of people that were told if they went to university and worked really hard, they would have an amazing job that would take care of them for the rest of their life? And it's very possible that many of those jobs, they won't disappear, but they will be, as I call it, deprofessionalized, where it will be possible to hire a much less educated person and essentially stick an AI in their hands to do the hard judgments, and then pay them so much less. We've seen it happen through globalization. We've seen it happen through automation of factories. The first instinct of CFOs everywhere is chase labor costs to zero. And AI won't necessarily, it may well create more jobs than it destroys, but how many people will be qualified for those very elite creative jobs? And how many will fall down into a sort of low agency service sector where they really are no distinguishable from anyone else?
Because has this got anything specifically to do with AI in the sense that you described many instances in history when technology has caused these problems, so it's displaced particular sets of workers and so on. Is this really the first time, though, that we know, we're thinking about that when a new tool has become available? Or is there something unique about AI and machine learning systems that you think will cause a bigger dislocation than the dislocations of the past?
I've got an opinion, but I'm going to shut up for a little bit.
Well, I mean, I think one thing, to echo one of Vivian's comments, one thing that's likely to be different this time around is that, artificial intelligence, machine learning will impact the world of work probably in substantial ways, and ways I think that aren't so easy to predict in any kind of detail, and there are like 10 different learned reports which all say diametrically opposite things, so that's more evidence that it's hard to predict. But I think one thing that is clear is it'll have a much bigger impact than previous revolutions, like the Industrial Revolution and so on kind of white-collar work in the way Vivian was describing. Many of those tasks can be done, or at least many parts of those jobs can now be done, or will soon be able to be done as efficiently or better using machine learning systems than the people who have had years of training. There are interesting questions about whether that will change roles in the way, first of all, calculators helped lots of people, but probably didn't drive too many out of work. I mean, there were people in the old days who were actually people called computers who were responsible for doing sums. They don't exist anymore, but they were a small segment. But calculators and then spreadsheets, they probably augmented our ability to do things rather than replaced. But I think there's a real chance that the impact this time will be on across the piece, but much more than previously at that level compared to, say, the Industrial
And
Revolution.
just so I can give it a little bit of a face, this is one of my favorite examples. It's not my own personal project, but there was this sort of notorious little competition run recently at Columbia University between a startup that had made an AI to read contracts and a bunch of human lawyers. And in the competition, they'd engineered these non-disclosure agreements, a form of contract, with a whole bunch of loopholes in them. And then they had the two groups go at it. The AI, and these are very rough numbers, the AI found 95% of the loopholes. The human lawyers found 88%. So whatever, they're only humans, so let's call it a tie. But the actual much more interesting number is the human lawyers took 90 minutes to read each contract, and the AIs took 22 seconds. Now, what you do with those loopholes, how you make judgments, that's still a fundamentally human task. But the vast majority of lawyers, particularly junior lawyers, spend their time reading contracts and finding loopholes, or doing case study work, doing busy work to learn how to be this other kind of lawyer. And it may well be that that kind of work disappears. Those tasks disappear, and then it becomes a choice. Do we do what Peter says, which is all of the lawyers, all of them that are out there, become sort of super lawyers, augmented in a moment. They know all the loopholes, and they begin thinking about what to do with them. Or do we say, well, gosh, then let's keep the 5 best lawyers, and we'll get rid of all the rest?
Yeah.
Well, wouldn't it be great if we could, have, instead of lawyers, just everybody is a super lawyer, and effectively, if we could have our contracts be read in half an hour with solutions as opposed to 5 days of reading and cost us, a tenth of what it costs now. It seems like everybody would be more productive. So, in a way, I think I think the role will change. So it's that version of, you said, right now we need to. We don't have a choice. You have to spend, your junior lawyers have to spend time reading those documents for loopholes, and they'd rather be doing more interesting things.
So I genuinely appreciate, because when I say this is a choice, I think it's genuinely a choice. And the ability of, I'm not going to describe it in the moment, but we built a little system that can analyze kids' artwork, and it adds to our ability of one of our systems to do some education interventions. So there are like 6 people in the world that study children's art and look at its implications for their cognitive and emotional development. And we took their work and we were able to build it into a system and train it on these kids' artwork. And now we give it away for free as part of this little system, which itself we give away for free. And in that sense, yeah, you can reach out. Probably even the better example is the idea that you could just even have a dumb mobile phone. If it can take pictures, take a picture of a mole you're worried about and have it tell you whether it's cancerous or not, or at least whether you should go in and see a doctor. That would be amazingly valuable. But in this question of, have we been here before? Well, it really depends, because we've been here in multiple ways. In America, we have this chain called Jiffy Lube. You bring your car in, forgive me if you have it here also, but you bring your car in and they change your oil and your air filter and do all this sort of work. Well, that used to be a middle-class job, where an actual auto engineer would come in and do the tune-ups on your car. Now it's a job you get if you didn't do so well in high school. And you have no agency. You just follow a script. A computer does all the diagnostic work. You do a little upsell on an air filter, and the car goes out, and the next one comes in. So all I'm saying is the overwhelming economic trend of the last 30 years has been towards deprofessionalization. It doesn't have to be. It could be very much what you're talking about, but it requires an explicit choice on all of our parts. And let me tell you, if you leave it up to the entrepreneurs of the world, we're going to try and extract the wage value out of the system and keep half for ourselves and offer the other half to you as a discount. And as a result, that class will disappear.
When's the last time someone used a travel agent, for example? So 10 or 15 years ago, travel agents were absolutely essential in the world because they were the only people who knew the complicated things and could read the airline timetables and so on. And they still exist, but I think we interact with them much, much less. Because it's possible to do most of these things yourself through various apps online.
We should, we've obviously gone over time already, almost on the first bit. I just want to, so very, very briefly, we've got a demonstration I want to go to in a minute, but just a question from Emily, the last question in this section, which is, so if you can be brief, how do you think artificial intelligence in films has impacted our view on AIs and the potential they have to help us?
How many people here have heard of a deep reinforcement learning model? Okay, there's a few hands. How many people have heard of Skynet? So there's a partial answer. I think most people's conception of what AI is comes from Dark Mirror, which is actually not a bad depiction of some of the ethical choices, if not great depiction of the technology. It comes from the Terminator movies. It comes from many, and it probably reflects more of our fears. I mean, it feels a little more deep spiritual than anything else. And I don't know that it's done a great service to anyone in trying to get them to understand the implications of these technologies.
Do you find this, when you say with the field that you work in, do people tend to use movie analogies and film analogies to imagine what you're doing?
Oh yeah, absolutely. People get very excited and fascinated and they want to know more. And immediately they think of not mathematics, statistics, and algorithms. They think of powerful robots. And so absolutely. And do I take advantage of that? 100% kidding.
It's interesting how often you talk about the future of work and people think what you're talking about is C-3PO is going to come and literally tap you on the shoulder and say, you're out. That's my seat. And there's nothing like that actually taking place.
Yeah, I should say, actually, there is a report, a piece of work that's been done by the Leverhulme Centre for the Future of Intelligence today, which is available. It's published today. It's available on the Royal Society website. So if you want to look at more of these questions, dig deeper into that question, you can go there to the Royal Society and have a look. I am going to go to this demo over here, which is a demo that's been set up. It's another example, in fact, of machine learning and AI. And so I'd like to invite to the stage Professor Adrian Hilton and his team from the University of Surrey. Thanks. Hello. I'll say hello. So perhaps you could just introduce the team, actually.
So we have Charles and Marco, and Hannah's going to perform live for us.
Yeah. So what are we going to do? This is using AI machine learning for motion capture.
Yeah, so what we're doing is converting video into 3D models of people's movement. Over on the left-hand side, you can see the kind of video input. What happens then is that's transformed into a three-dimensional representation of the person's movement, and then we can map it onto a character, both indoor and outdoor. So this is a very portable system.
Yeah. And then what's the breakthrough here? What are the difficulties in capturing human motion?
So what machine learning and AI has enabled us to do is take this video data and really extract some high-level understanding. So in this case, what we're doing is understanding that there's a person in the video, and on top of that, we're understanding where their joint positions are in that video. And that's something that we've not been able to do until the last few years, and it's a powerful technology, in this case going into the entertainment industry.
Yeah, because I suppose I used to see these things in film, and there used to be little dots all over everybody, so you could see what the visual system was doing. But in this case, it is just looking at a person, isn't it? So there's a lot of intelligence in there to recognize that's a hand, that's a head. Is that
exactly
difficult?
So what is happening is the AI machine learning is taking the video and detecting that there's a person there, and then labeling the body parts of the person purely from the video. And the challenge really is to be able to do that in complex scenes. So in someone's home, for instance, if you're detecting their motion, or in an outdoor scene like we just saw.
Yeah. So we're going to see, what are we going to see here?
So up on the top left,
we have
Hannah.
on.
It's just calibrating itself.
Yes.
And then in the middle, we have now Hannah moving, and her movements conveyed in 3D. And then on the right-hand side, we have a computer-generated scene of the Barbican courtyard, which is directly above us here, and the model being animated in that scene.
I see. So there's got to be, there's the recognition part of it, but there's also a human model in there to say, this hand is moving in this way, so this is how we would map that onto the
So the AI is mapping out where the person is in each view, and then we combine that together into a three-dimensional model.
Yeah. What are the applications? I mean, obviously for filmmaking, this is useful, but what are the other applications?
So this system was specifically developed to get around some of the problems in filmmaking and games production and things like that, so to have portable systems that you can take and put on a set. But the technology itself is applicable to a wide range of things. So for instance, one of the things we're looking at is the use in healthcare and how you can have very passive sensing technologies that will be able to understand your movement and behavior. And why is that important? Well, if you want people to be able to live at home independently for longer, then you have to have systems that can understand their behavior, and particularly when there's changes in behavior, because that signals that maybe they have an infection or something like that. So we've actually shown with some of this technology that using, again, machine learning, you can pick out some of those characteristics from relatively simple behaviors.
Yeah. Well, do you think I should have a go? Just to see, so you can see that it doesn't only work with a trained dancer. I'm going to go and... So could you talk through what's happening? So as I stand here, so the first thing I have to do is find...
So what's happening? So first of all, you can see the images up on the screen there. And what we have to do first is just calibrate the two models, because we've got Brian in the picture now. And then
there's a skeleton.
It should be that it's now picking up his motion, and he's being converted into this lovely skeleton. He's changed into another character here. So you've got a very simple pipeline without wearing any sensors or anything like that can really interpret someone's movement and behavior. And that's one of the kind of powerful technologies from AI.
So in terms of processing power, how long have we been able to do this? Well, what's the difficulty? Is it the algorithms? Is it the computer power? Is it a collection of all of those?
So the real challenge has been, how do you analyze an image in a general scene and understand that's a person? And we've all got used to, over the last maybe 10 years, to our smartphones having ways to detect faces. But this goes a long way beyond that, and it's only been the last couple of years where we've really been able to pick out people in general scenes and then convert that or analyze that motion. Yeah. And that's down to machine learning, understanding from very large groups of images what a person looks like in an image. And the variety of people in the audience here with different clothing has to deal with all that complexity in the understanding.
Yeah. Oh, very impressive. So, yes.
Thank you.
Thank you very much. Thank you. Thanks. Thank you. Clever stuff.
I felt I was receiving a lecture from a superhero with Parkinson's.
Yeah. Yes. I know, they chose a very flattering sort of, I don't know, Iron Man type thing for me, didn't they? It could have been anything. Anyway, the next question, this is a question from Alex, who has asked, who will be the last... Oh, we've talked about this a little bit. It's interesting, because you talked about... I made the mistake, I think, of thinking that new technologies always displace less skilled labor, less skilled jobs. And you said, no, it's perhaps the more professional classes that should be more concerned. And the question relates to that is, who will be the last employed, right? But there's a question, is it creative artists or software engineers? So I suppose going to the essence of what's the most difficult thing for an AI to replace?
I've now taken the lead here on the whole thing. So this will be an absolutely shameless plug. I have a book coming out next year called How to Robot-Proof Your Kids. And the heart of that story is that there are some good answers to that, at least for the time being, until something more advanced comes along. But when we look at the sorts of things that generalize the best, this idea that the future is unknown, well, let's build people for the unknown. Rather than trying to guess what you ought to know, I think all of those reports, the one thing that those future of work reports seem to have in common is everyone should go learn how to program, which is one of the skills I've literally seen an AI do, where a designer just describes the website that they want and it writes the code. And so in 10 years, if most of the code isn't written by AIs, I would be rather shocked. There'll still be people writing code to build really novel database structures and going out and exploring the unknown, but there probably won't be people writing a bunch of boilerplate code just to fill in websites, which is the core of these jobs. But that points to the other side. No one's really developed AIs, in a sense, to explore the unknown. So when you look at the qualities associated with that, things, and I'm going to be very broad here, like emotional intelligence and social skills, creativity and metacognition. Those are the things that even talking about AIs doing those sorts of qualities doesn't even make sense because they don't really have emotions to have intelligence about. So when you look further at who are the people that have the most creative jobs in the world today, and I mean creative very broadly defined. So scientists are creative, and so are engineers, but so are the people that are usually on this stage. Those are the things that will be the hardest to automate. And really focusing our education system and even our hiring on those sorts of qualities rather than focusing on a bunch of rote skills that 2 years from now you're going to have to retrain again is the heart of the sorts of qualities that we need to look for.
I think that's the point that you made earlier, isn't it? That you open up possibilities by enabling people to focus more on those really productive areas, even lawyers, you said, actually, the creative nature of the legal profession.
Absolutely. And I think in general, if you think about, LSATs and MCATs, the entrance exams for medical school or law school, at the moment, they mostly are testing for, what we typically describe as IQ. But increasingly, I think schools should change their admission criteria to focus more on EQ and identify individuals who can balance the two, because that's where these professions will shift.
No, just,
You're going to agree with everything?
I am going to agree again, and I think...
I'm going to come to you first next.
I think this question of how...
I believe in the Nazi philosophy.
I don't agree with that.
Okay, great.
That proves I'm not a machine or that I am a machine.
Do not quote me out of context. Things are bad enough in America as it is.
It's being broadcast online. People are just going to clip it out and put it on Twitter.
I think thinking about the right way to train and retrain people is a major challenge for us. I mean, there are obvious things about helping people learn to think in the kind of old-fashioned sense rather than just to know and learn things. That's bound to be increasingly important, and we need to be thinking about that throughout both the standard educational curriculum and then the rest of people's lives.
But let me add in a really fascinating finding. So for a little while, I was the chief scientist of one of the very first companies using AI for hiring, which I hope we talk about because it is one of those very profoundly controversial things. And we had this really interesting finding. We built a database of 122 million people, of which 11 million were pretty much all of the professional software developers in the world. So I mentioned social skills are one of those things that are robust to displacement by computers. So in fact, we found social skills, empathy, perspective taking, communication skills, you could go on, were very predictive of people's quality of work. And in fact, just as predictive of the quality of code written by software developers as the amount of sales by salespeople. Yes, it was much less common for software developers to have super strong social skills, but when they existed, they were just as predictive. So one of the misinterpretations of a question like that is, oh, well, then we need to train everyone to do social jobs. Care for the elderly, which is a wonderful job, but the economics aren't great. Greeter at a store. But in fact, every job is made better by understanding other people. And that's a really important thing to remember.
Yeah. OK, well, let's move on to section 2, which we called How Could Society Benefit from AI? We've sort of covered many of these issues. But Malcolm has a question. So I'll come to you first, Peter. So the question was, if a computer gives me a diagnosis, should it also have to explain how it reached that diagnosis?
It's a really, really interesting question. And I think there are a couple of different levels of it. There's a specific question in the context of diagnosis. There's a much more general issue about these AI systems, which is how important is it that we understand why they're reaching a decision. And it's worth saying by way of background that many of the incredibly successful systems, there's no sense in which we can ask them, why did you get that decision? We can just measure how often they get it right. And there are very interesting questions about the extent to which, in different contexts, we value the ability to be able to understand the reasoning behind the decision. And I think those things tend to be context specific. The question was, explicitly, I think, about medical diagnoses. And as part of the Royal Society's work on machine learning, as Brian mentioned earlier, one of the things we did was outreach, and we talked to people. Ipsos Mori helped us to get people's views. And actually, those views were very interesting in the context of medical diagnoses. Let me not tell you what they are. Let's actually do the experiment, except I can't quite see. So imagine it's got to be slightly hypothetical, and you've got to vote for one of the two possibilities here. You're sick with something pretty serious, and you have a choice of having your treatment decision made on the one hand by the consultant at the local hospital who's good at his or her job, and we know from lots of data that they get this decision right 90% of the time. So that's choice one. Choice two is you can have an AI system examine your symptoms and make a treatment decision. And again, we know from lots and lots of data that the AI system gets it right 97% of the time. And except that there's no way you're going to understand the decision that the AI system has made. Okay, so you've all got to vote. Unfortunately, we can't see very easily where you're voting. So in those situations, you're seriously ill, slightly hypothetical, as I said. Who would choose the doctor who gets it right 90% of the time?
So hands up, the doctor.
And who would choose the AI system?
Wow, this is a really biased audience.
Yeah. Oh, but it was about a third or two-thirds.
Yeah, so I think
How many of you are wearing a badge that says, I love C-3PO right now?
I think this is a Royal Society event, so it's just a statistically literate audience. It's good you said 97%.
Now, I haven't quite finished with my experiment, so let me finish. So I think different people take different views, as we've seen. Now, if I give you a third option, which is, actually, you can have your doctor who gets it right 90% of the time, who knows the result of the AI system that gets it right 97% of the time, and can revise his or her opinion, who'd go for that? Yeah, so that's kind of easy. That's the sense in which probably these systems will augment, at least in that kind of medicine, they'll augment what doctors are doing. Final version of the question. Those of you who have, let me ask it a different way. So here's something complex that gets used all the time in medical systems, MRI scanners. So they work on pretty, well, it depends on how into physics you are, but from a distance, so fairly sophisticated physics. There are complicated algorithms that interpret the raw signal from the machine that gives something that gets fed back to the doctor. I think it's probably fair to say that many of the doctors who do a brilliant job of reading the outcomes of MRI machines or CT scans or PET scans or whatever don't understand any of the details of the algorithm. Now, somehow that doesn't seem to worry us currently. We just know that they work well because we've checked. So I think, as I said, it's an interesting question. That ability to understand the decision is a good one. Last version of my kind of audience participation. How often do you think in those complex situations when the doctor says, we think we should do X because, and then there's a kind of short, simple statement, how often do you think you actually really understand the doctor's thinking and the reason the doctor came to a decision?
It's about 2 people.
Okay, some of you...
They're both doctors, probably.
Some of you do. And so the question for us is, when should we want different... when should we impose different criteria about decision-making from algorithms from that of people? I mean, people can give an explanation, but we know from our daily experience that most of the time the explanation, well, that's not aimed at any of the people I interact with all the time, but sometimes we experience the fact that someone comes up with an explanation after the fact, which isn't really an explanation. It's just, it's a way of them saying, or just justifying what they've done. Anyway, long answer, but I think it's complicated, and we have to think hard about it.
Suchi.
I think, sort of building on what Peter said, though I don't entirely agree with him because I have to disagree with him. This notion of, I don't actually think we need an explanation. What we need is the ability to trust and the ability to work together. It's that example, the lawyer example, contract reading example we got earlier from Vivian, but also the same thing in medical diagnosis. If you had a way of knowing, when you interact with a trusted colleague, you understand how they work, you understand how they think. They're going to say something to you, helps you build your own thinking, which allows you to evolve and say something that they react to. And that notion of collaborative reasoning is what we need for such systems. A thing that's really exciting and powerful here is that, computers possess the ability, these algorithms can look through tons and tons of data to determine in any given scenario, what has happened to other patients who were in the same scenario and what was done and how they reacted, and can summarize it in a very nice and succinct way. So what this means is, if we could figure out a way to build complementary expertise where we can use that knowledge to be able to collaboratively arrive at a decision, I think that's where we want to be at. But I think this is an open science and something we're actively working on.
Yeah.
So I can give a very personal answer here. 7 years ago, just before the US Thanksgiving holiday, my son got sick. And it wasn't clear what it was at first. But that was a Sunday. By that Wednesday, he'd lost 25% of his body mass and couldn't stand up. So we rush into the hospital. And it turns out, in retrospect, it should have been obvious. You could actually just smell what was wrong with him. He had type 1 diabetes, and his sweat was sweet. Now, I got some fancy-smancy degrees, but it turns out being a neuroscientist doesn't mean you know anything about diabetes per se. So that was a very hard, long 4 days in a pediatric intensive care unit. My wife and I both happen to be scientists, so the minute we come out, we record everything. We were crashing Google Docs on a regular basis, recording everything he ate to the gram. Did he have the sniffles that morning? What was his blood glucose readings? What's his heart rate? Everything. And then before I go in to meet with his new endocrinologist, I don't know how many people here get to have an endocrinologist, but that's a fun part of your life. And she's someone I really respect, and she's still his doctor. I emailed her all of this data, thinking she's going to love this. and we got no response. So I figure, what's going on here? I mean, I love data. Then surely all of you love data. What's wrong with this woman? So then I realize what it is. So I print up about an inch thick of spreadsheet and bring it in with me and plonk it on the desk in front of her. And they were pissed. This was not what they wanted. What am I supposed to do with this data? So instead, they gave us a little photocopied sheet. Diabetes has gotten better even in the last 7 years. But at the time, they gave us a little photocopied sheet. It had 5 days, 3 boxes for each day, morning, afternoon, evening. Write a blood glucose level in each box, 15 numbers. We had 15,000 numbers. But what a human can't really process 15,000 numbers. But I'm going to admit, and forgive me if I'm reading the room wrong here, but this is my genuine feeling. You've got to be fucking kidding me. I make models of the brain. Are you telling me diabetes is more complex than the brain? So that night, I bought a book on endocrinology. And the next morning, we hacked all of my son's medical equipment. Turns out we broke several federal US laws. And I redirected the data to my personal server. And then I took a model of predictive coding in the retina. I don't know if you realize it, but your retina literally predicts the future. And I repurposed it for diabetes. The details don't matter, except that it really helped. I mean, it profoundly helped. It allows the insulin pump to sort of make its own decisions. And there's all sorts of implications. It was wonderful, and we got to give it away, and all sorts of things. I got to admit, I don't care what my endocrinologist has to say about the treatment for my son. I care what my model has to say. Her job is all the stuff that's not day-to-day, because it's day-to-day. Literally every 5 minutes, it gets a new number and it makes a new judgment. And it updates the model, and there's a very exciting, lots of new work in this space. We've been able to do the same thing with bipolar disorder and work in Parkinson's. So what I'm getting at is I actually think models ought to be explainable. Both in medicine and in a variety of other domains. I need to be able to tell you why I didn't hire you, or maybe why I did. But it doesn't mean you have to understand the model. It doesn't mean that we have to probe the and sometimes incredibly complex interrelations of a very, very big system. But somewhere along the line, if you've been denied a loan, or a job, or if a judge doesn't believe you for some reason that won't be disclosed, you should have a right to understand why. And if they can't provide you with one, you should be able to second guess it. And in the case specifically of medicine, this is why, because there's no right answer to the treatment. So understanding you, what it means to get this diagnosis, what kind of cancer do I have? What does it imply? How does it interact? I think there's cool ideas about how AIs can explore vast possible treatment plans also, and then linking a whole bunch of them together. But somewhere, I believe, there should be a person, and there should be a why. And it should be something that you actually understand, because otherwise, we need to think about what happens over time when we get very used to the idea that there is no intelligence the way we understand it in a system making these decisions.
It is interesting, isn't it? Because it's some of the issues we're discussing are not specific to AIs. I mean, in this case, it's the human need to understand if a mistake is made, which I might mean the wrong diagnosis, even though 99% of the time the expert system might get it right, as opposed to 90% for the human, we want to know why the mistake was made, don't we? And the brutal statistical approach would be, it doesn't matter because it gets it right more often. I mean, you see this with driverless cars, actually, don't you? As well, the question is, well, driverless cars will be much safer than human-controlled cars. But when the car runs over and kills a pedestrian, we want to know what the decision-making process was. But it's our...
It's probably because I tweeted something nasty about Elon Musk.
Yeah, it's kind of, in a sense, not particularly logical and not about the AI, isn't it? We're more talking about the need to know why it may have made a mistake.
I don't know if that desire to know that in that instance is logical. In other words, I'm conflicted at this choice of if I had a system that was 99% accurate versus using a system that was only 90% accurate. But one could make up an explanation, like Peter said, though we had no way to assess if that explanation was correct,
Yes.
versus a different system that happened to say, I don't know. Though I disagree, I actually think we can hold these algorithms to a much higher bar. And there's a lot of creative work going on in being able to elicit explanations that can allow you to collaborate with the machine. But even in that dire scenario where the system said, this is my decision, then unless the issue is that when it gets it wrong, it gets it very wrong, and it's very damaging, I would say we should be willing to operate with the 99% accurate machine.
Yes, I agree. But it's
Yeah.
So that's why I was thinking the heart of this question is should the thing have to explain how it got to the...
Well, maybe it should.
That's the point, isn't it? What we're saying is, well, no, if it gets it right most of the time and more often than the human, it doesn't matter. Is that the consensus?
I think for some people it'll matter a lot, and for others it'll matter less. And people might want to take their choices there. I mean, as Suchi was just saying, there's a very, very active area of research within machine learning, which is about building systems that are much better at explaining why they got there, and it must be in everyone's interest for that research to be supported and strongly developed.
So it's fascinating. Peter and I were actually at an event, Royal Society plus National Academy of Sciences event in Palo Alto, and there was a young man who is making this very provocative statement that the understanding of explainability of AI on its face is silly, and gave all of these very, very good reasons for that, all of which apply to us. Every single reason he gave for not bothering to understand AI applies completely validly to understanding our own minds. And I hope we don't take that as a policy position of why bother understanding why we make decisions either, because really it feels very parallel to me.
Okay, so let's get to another question from Jeremy. Perhaps we'll start with you, Suchi. The question is, given how much Google already knows about us, should we be worried about them getting into health?
Oh boy. Who is sponsoring this event again?
Google.
They did pay for my flights. Somebody did.
I suppose we don't have to, that was the question, but we don't have to a specific company. What we're saying is big companies have a lot of data about us in general. Apple also have a lot of data, and they have nothing to do with this event at all.
Good point.
But it's a good point, isn't it? So health, I suppose, it's the most personal of data in many ways. I suppose that's the point.
Yeah, I do think, I think that's a great question. It's a very interesting and a tough question. I don't know if I can really answer that question with like 5 seconds of thinking, but I'll take a crack at it. I am concerned about, I do think it should be concerning to us if a small number of corporations or decision makers have access to both a large amount of data and a lot of the requisite skill set and personnel to be able to develop these types of approaches. Yeah. So I do think it's important for us to decentralize, but I don't think that should happen at the cost of us not having access. So in other words, if I had to choose a world where we could use machine learning, we could take advantage of a group of individuals who could develop really smart algorithms that could then allow us to improve healthcare, I would absolutely support that. And I'd prefer that over a world where we didn't have it. But my preference would be we decentralize the development of these and we broaden out education, we make funding available broadly, and build systems where, you know, like the data isn't sort of held or bound by a single organization and people involved.
Yeah, and
so,
this is quite specific, isn't it? Because Google as a company are providing services
right.
to the NHS and such like in the UK.
Yeah, and I think there are really interesting and special issues about healthcare data. I mean, it's true that Google and many of the other tech companies have a lot of information about us. In a certain sense, that's because we consent to it. Now, you know, we tick a box after pages and pages of consent forms we don't read. But I think everyone thinks differently about healthcare the data in healthcare systems. Certainly the healthcare systems themselves do, and I know in our case in the UK, it's something the NHS and our politicians think very hard about. There's huge potential in the data from the NHS to analyze that in ways that will lead to improved efficiencies, to better outcomes for individuals, for people living longer, avoiding complications, being given the right drugs, and so on. The potential is massive in the data in large healthcare systems, and in particular, we're in a very special place in the UK because we have a single provider system. So the potential's there. Nobody wants to kind of give that data away to companies, well, for two reasons. First of all, I think because we naturally think of the NHS as sort of our resource. It's something people in the UK care strongly about, rightly, I think. So any version of that data being used must have benefits both for the NHS and for those of us in the UK who are patients within the NHS system. But also because we all appreciate that healthcare data is special and even more private. So there must be, and encouragingly there is, a kind of serious debate going on as to what are the right levels of safeguards, what are the right levels of anonymizing data that might then allow that data to be made available exactly for these potential benefits to accrue. And I think the other thing to say, which is obvious, is that I don't think anyone would say it should only be the big tech companies that can benefit from that. There'll be lots of small startups, actually I run one myself, but there'll be lots of small startups who can play a role in that as well. So we need to think really hard about healthcare data. We've got a fantastic opportunity in the UK, but we absolutely need to get it right and understand the right way to respect privacy and anonymity, the right way to have a dialogue with those of us who are, all of us effectively, who are patients in the NHS, to make sure we're happy with the benefits, to do everything we can to minimize the potential downsides, and that they're real, but we can do things to minimize them, and then to make sure we're happy that the upsides are justified. And my own view is that the potential is huge, but we need to get it right.
Go ahead.
Just to add to that, I think there's also this, I mean, I could imagine as, it's certainly this way in the US where large health systems, which are large enterprises, they prefer to interact with large corporations or companies because they inherently think that they're probably able to store the data more securely and keep it private. And as a result, you know, implicitly they're creating a scenario where they're locking down their data with 1 or 2 or 3 large organizations. I went to school in California, in the land of you know, startups, and you know, historically my experience has been that some of the most innovative and disruptive ideas come out of small groups of people who are mission-oriented, who are completely committed to making a difference. And so as a result, I think in this area at least, what I see is this mismatch in potential where, you know, the ability to make change by small groups, small companies who may be well-equipped, but large enterprises are, you know, very skeptical or afraid to work with them.
So I want to expand this a little bit. Healthcare is great, but it goes beyond that, in my opinion, and also expand beyond the question of data. Data has been a big issue here. The whole idea of GDPR is to protect people's data. Health and education data about kids, everyone gets very productive in all over the world. The one place where they're really productive about data in China, for example, is around kids. But here's the thing, if you don't actually have any ability to actually exert a right around your data, and yes, I realize through GDPR there's a lawsuit mechanism, but right now someone's misusing your data. What are you going to do about it? File a lawsuit so that 6 months from now we'll lose in court. That's not very satisfying. Right now, one of the biggest advantages these large companies have, and I don't think any of them are bad guys. I've done collaborative work and been recruited to work at almost all of them. It might say something that I never said yes, but nonetheless, they're not bad guys. They are all guys for the most part. Is that they don't simply have masses of data no one else has available to them. They have masses of talent because they have raided the university system. And I'm not out here to tell anyone they can't go get a big paycheck, but when Google will throw $1 million bonus at someone just to keep them out of another company, that tells you something about how they value talent. And they also have infrastructure, which is hard to find anywhere else. Even for my own companies, we can't run massive scale, high throughput GPU systems on our own. We don't build that stuff. We use Google's. So they have a monopoly on multiple dimensions in this new AI space. And that does genuinely concern me. Now we can actually throw in China and America themselves as formal entities as well. A very small number of entities essentially control all of the computing power around artificial intelligence in the world. And I could build a company, and my best hope is to get it bought. The likelihood that I will become a massive new competitor to Google or Facebook is virtually zero. Most of my work is philanthropic, but I'm still under these same constraints. I have thoughts about this, but I just want to put out there, instead of my own personal philosophy, how do we think about how we as individuals are able to exert our own rights to how decisions are being made about us? Not just control of our data per se, but the same way we have a right to judicial review, the same way that we have a right to seek a second opinion from a doctor, I should have a right to how AIs are targeting me with their ads. I should have some participation in how these systems interact with me. And right now, none of us have any. And I'm as empowered as you get in this space, as you heard through my diabetes story. But I am not going to engage in that because I don't have enough time in my life to build a separate AI to deal with everything. And I think we really need to think, right now our homes are filled with these little embassies. Embassies from Amazon, embassies from Google, from Apple, from Baidu, from Alibaba. And these are our phones and our smart home systems. And they operate under their own laws, even though they're in our homes. Wouldn't it be great if we could think of how we could operate in the public interest, in the public trust? I don't necessarily mean governments, because I'm throwing them in as part of that concentration of power. How do we actually exert our right to make decisions about our own life?
Okay, well, let's... I didn't mean it like that. I thought I could... The point is we could talk about that. It raises so many issues, but we've got about, 20 minutes left or so, and quite a lot of questions and a whole section to get through. I just want to, so very briefly, there's a couple of questions here which are sort of linked about the future. So maybe we could briefly address these. One is to look into the future to see where AI is going in a biological sense. The question is, will there be artificial intelligence created on such a level that it can perhaps fight cancer and various other diseases, perhaps begin to... I suppose it's looking at the potential in biology. So maybe briefly take that one. How far are you away from... AI has been used in that respect?
I mean, they're already being used, not kind of just in their own right. So science in biology, cancer, biomedical sciences, there are increasingly larger and larger amounts of data. Our ability to read exquisite detail about biological systems is unparalleled, and it's exploding rapidly. We can study individual cells and realize in a cancer tumor, for example, we can realize what's going on that's different in each of the individual cells in the tumor, and how some of those have some properties that will ultimately lead to resistance to a particular drug regime and so on. So that area of science is massively, massively data rich in a way that just hasn't been true for most of certainly biology, human biology's history. Where AI systems will be incredibly helpful there is in helping us as scientists to make sense of the data, to learn things from the data. And that's already happening, and it'll keep happening. And it will be one of the big drivers of the progress we make, in fighting against cancer and in improving medicine more generally.
And that was from Jaffa, by the way, that question. Do you have a...
Yeah, I agree with Peter there. I think I kind of think of it as the spectrum from discovery to delivery. So discovery is, discovering new ideas about human biology, how our body works, how do we characterize disease, to delivery, where we will figure out new and more efficient ways to get the right medications and the right therapeutics and to the right people. And I think that entire spectrum in the last 5 to 10 years has been going through a transformation. I think in the next 10 to 15 years, we'll see some of the most exciting discoveries. And even in our own work, we've seen disease areas where physicians had a hard time diagnosing it, but now by working with machines, they're able to not only diagnose it sooner, by getting treatments to the right patients, they're actually seeing improvements in conditions.
I just want to ask this final question in this section. It's a fascinating question, actually. It's almost like a Blade Runner-esque question in a sense. It's from Will. And he asked that in the future, will there be a section of society, he calls it an upper echelon of society, actually, maybe the very rich, who completely shun AI for a more costly human experience? So the ubiquity of AI.
This is the version of wanting to use a travel agent.
Yes.
When you can go on
it is,
kayaks.
It may go even deeper than that, I suspect.
A human travel agent.
Let me just go back. So in the Royal Society's work, we tried to engage and get people's views. And one of the things people were genuinely worried about in the growth of AI was a kind of depersonalization of experiences. So it's a legitimate concern, and it's something that people in general worry about, and I think we should be thinking hard about.
I actually think AI will make experiences more personalized, not less personalized, because by knowing a lot about you, you're able to identify, imagine when you go on a trip, you want to find the people who are very much like you, see what they enjoyed, and based upon that determine what would be fun to do. And right now, it's not really easy to figure out who these people are.
So again, I've done a lot of work in education. In fact, in education, there's a term for this, personalized education. And the whole idea is to use technology, and in particular artificial intelligence, to target kids with just what they need. But this is what I brought up before, the difference between our aspirations and then the way it actually gets used. So the term personalized education has, frankly, in common technological terms, simply means where on a fixed track are you? And so, in a sense, it profoundly depersonalizes the experience of education by putting everyone on the same educational track. And then it's personalized because it places you at some level. If you're different than that sort of that trajectory, then it doesn't account for you at all. So it is possible for us to build those models. And I do a lot of work that myself. But the truth is, it's a lot easier to build a much dumber model that doesn't actually personalize everything. It just has it as a marketing term. And that gets really disturbing and disappointing. But I actually want to offer a contrary proposal. I very much understand this idea of, and people have thrown it out there, that imagine some day when only the wealthy can get their hair cut by an actual human being. You get to exert your authority by ordering people around.
I have a real assistant, not Alexa. I've got
Yes.
a real Alexa.
I actually think it will be the exact opposite. So very early on, I answered a question by talking about this idea of general artificial intelligence versus the sort of thing we are now experiencing. And I said I didn't know when, if ever, we would invent such a thing. However, and this is a bit provocative, I think I can give you a very rough timeline for when there are people that are artificially smarter than other people. So one of my fields of research, in fact, my core academic field of research, is what's called neuroprosthetics, which is really the literal merging of computer systems and people. So we have 3 organizations, for example. One is working on people that are locked in. They look like they're in a coma. We're building systems to allow them to communicate with the outside world. Another one is working in performance optimization in athletes, less interesting to me, but I get to learn things through the collaboration. The last is perhaps the most provocative, which is a company called Hum, and we're helping them build a technology which it turns out exists. You can go pre-order it right now. It's a wearable headband, so not yet jamming things in your brain, but we're getting there, so I'll take volunteers. The survival rates are so-so. But in this case, with the Hum band, you flip a switch, and working memory increases by about 20%. So I don't know if anyone's ever played the Simon game, you know, where you push buttons and colors in a row. Largely in this audience, most people will be able to go up to about 5, 6, or 7 patterns before you start to, you can't quite remember which pattern it was. And we flip the switch, and it adds 1 or 2 to that memory span. Now, that may not sound all that exciting, but people with the larger working memory spans literally live longer. They go further in education, they earn more money. It's not true on an individual level, but sort of at a population level. If some of you are 7s and some of you are 5s, you will have much better lives. And now we can build a device that makes you a 7. Now, that's probably not what this device does. At least you shouldn't be wearing it long term. Trust me, I'm not selling this to you. It's steroids for your brain, and God knows what the long-term implications are. But we're helping develop this because, for example, kids with traumatic brain injury, you know, maybe they fell off their bike, and in a moment, who they could have been was taken away from them. And so we're developing an educational intervention to be paired with it. 15 minutes a day, we flip the switch, we do a deep literacy and math intervention, and we try and put the pen back in their hand to write their own life story. If we say no to technologies like that, then we're saying no to changing the lives of all these kids. But by saying yes to it, we are saying that sometime in perhaps the not too distant future, we might be fundamentally changing what it means to be human. And the ultimate question there is for whom? And I think if we're talking about the wealthy and these sorts of technologies, it will be inevitable that there will be an effort for them to get the first access and to be it a Sweet 16 gift for their kids. Actually, it work much better if you do it when they're babies. And I love experimenting on defenseless orphans.
That's another of those clips that's going to be snipped out.
But is this a human right, like a vaccine, or is it something that the wealthy get to do before anyone else does? And it shouldn't be me that makes that decision. No matter what I think of myself, this should be a decision that we all make. And right now, I feel like that's not happening.
Yeah, or indeed the market, which is the sense of the question. Okay, well, let's move on to the final section, section 3, which is titled, How Do We Get There? So I suppose the route to the future, to be sort of rather broader. There's a question from Gary who says that AI could be a brilliant opportunity to expand our knowledge. Should there be restrictions so that it does not become, that knowledge doesn't become owned by big corporations? I suppose it crosses over to what you've just been saying, actually. I suppose the regulatory framework. So perhaps we broaden it to that.
Sure. I think I certainly think there's a mixture of, Hollywood painting movies with, strange abstractions that aren't quite real depictions of AI, but sort of evoke an image of apocalypse and, the Terminator and so on and so forth. So I think that's motivating our understanding of what we need to regulate and how we need to regulate. Let's take a step back and go to the right. Like, how do you regulate math? I mean, that's kind of a strange question. Should we be regulating math? How do we regulate math? If we go one level deeper, the use of math in, say, making decisions to decide whether to insure somebody or not, now we can start thinking about it in a much more concrete way, which is, yes, we should not deny insurance to somebody with a pre-existing condition. So effectively, I think in the same vein for AI, we'll need to go several levels deep to understand very specific areas where AI will be used, how it's being used, and then determine what the appropriate regulatory framework will be. And we very much need broader education to engage people from other fields, to think about the ethics and the consequence of its use in a variety of different scenarios.
Yeah, and is this really any more complex question than talking about any other new technology? We regulate everything, don't we? We regulate aircraft, we regulate cars. You have to, don't you? So is there a specific issue here that makes it more complicated to regulate?
I think one part of it, and I entirely agree with Suchi, is that we need to think very differently in different contexts. And some of those contexts already have a pretty good regulatory framework. So if AI technologies were to be used, they're not currently used, but if they were to be used in flying aircraft, then there's an incredibly strong regulatory framework that would be involved in testing them. If they're used in medicine as new medical devices, again, there's a framework, may or may not be perfect for this purpose, but there's a framework there that thinks about how to do the regulation. So I think we need to think different, because the costs of getting it wrong are very different from flying a plane to recommending the wrong movie from Netflix. And we need to respect that and see the different contexts. Some of those contexts have good regulatory frameworks. Some which near Vivian will have a better sense in education may or may not have them, and others don't have them, and we need to start thinking about them. But we should deal with it differently in different contexts.
Having guidelines and regulatory frameworks, principles being laid out. I met with actually someone today from the UN. They have a big council that sort of, should we have some principles about how data and artificial intelligence get used in the world? I genuinely appreciate these sorts of things. But frankly, I don't know how clearly people make decisions, particularly decisions that are very technically complicated and be very hard to understand for anyone else, about how they deploy these sorts of technologies out in the world. One of the things I've heard is we should have ethics classes in computer science schools because it's worked so well in business schools. I actually think this isn't a magic solution to anything, but one of the interesting things, and I'm going to labor through a metaphor here, but I used it earlier, that artificial intelligence is an exquisitely powerful and sophisticated tool. It can't make decisions on its own. It can't solve your problems for you. If you don't understand the solution, it's very unlikely, in my opinion, that it will figure it out. But it is immensely powerful and completely changing the economics of those solutions. The problem as I see it, and I'm not here to criticize computer science schools, but I am going to say this, that we sort of deploy this army of largely very young and certainly very male machine learning experts that have spent their entire very short career learning how to construct a hammer, but they've never actually built a house. They get given, and this will be a little wonky, but they'll get it, they get given these perfect data sets like ImageNet, and they're asked to solve pre-specified problems, like name all of the breeds of dogs in these pictures. But what they don't get is a 4-year-old with diabetes. What they don't get is, here's the hiring history of Amazon, build a deep neural network that hires the right kind of people. Well, Amazon tried to recruit me to do that, and I told them it wouldn't work. But they went ahead and did it anyways, and if anyone read the news about this, it wouldn't hire you if you used the word women's on your resume. Take what you will that says about Amazon's hiring history, because that's where it learned it from. But this is one of the most sophisticated companies in the world. It has an army of machine learning experts that they brought in-house. And they ended up having to drag this thing around the back of the barn and shoot it in the head because it was unresolvably sexist. And they tried for a year to fix this problem by manipulating the data sets and manipulating the algorithm, and it didn't work. So I really want to be incredibly careful that maybe part of this problem, not the total solution, but maybe part of this problem is actually training people on how to solve problems rather than how to build models.
We're almost out of time. I wanted to get to the... There's a question, I think we've covered the question. There was a Nandita who asked, what impact could the growth of artificial intelligence have on society? I think we've almost answered that in every question. But
Are
maybe,
you saying I'm
I'll tell you
talking
what,
too
in
much?
one word, right, let's say positive or negative. Let's do that. Just what impact do you think, you don't have to answer, maybe I'm putting words into your mouth. One sentence, what impact do you think it would have?
I think it'll impact the world positively, dramatically in almost all spheres of our daily lives.
If we as a society get it right, we pay attention to it, and we get involved actively as stewards, I think the potential is huge and positive.
Yeah. And
You all insist AI is used to make better people. And I believe it could actually have a positive influence in the world, or I wouldn't do this work. Right now, I'm not so heartened.
Okay, and I can merge the final two questions actually, one from Minhaj and one from Chris, because they're very similar. One is, do the panel think that we will ever achieve a general AI, or will it remain a fiction? And a related question, I think, which follows on from that, if the answer is yes, is do you think we will always have control over the AIs in our society, even if they begin to demonstrate higher intelligence than humans? So there's two related questions there.
This is an exciting one.
Yeah, so since I get to study brains and machines, I fundamentally think we are a phenomenally complicated computing system. Nothing like any of the AIs that anyone's ever put together on an actual computer. But in that sense, theoretically, there's no reason why we shouldn't be able to do this. Practically speaking is a different question. We'll need a whole new set of models. So I got to do this one really fun thing once. At a conference, I got to debate this guy named Ray Kurzweil on stage about artificial intelligence. So he wrote a book called The Singularity is Near, about the emergence of superintelligences. He thought it'd be great. Like, they'll make so much better decisions. They'd never vote for Brexit, sorry, or Trump, or what have you. All right, clearly not everyone agrees with that. But you know, we had this sort of debate about superintelligences and so forth. And one of the things a lot of people don't even think about is if we invented something like that, would it even care about us? Would it, in fact, even have a conversation with us? Where's somewhere we might need such a superintelligence? Not to drive a car, because we already have dumb intelligence that can do that, us and the existing systems. Maybe to manage the entire transportation network of Britain. Something that has to manage this massive distributed system and optimize all the pieces. It doesn't have two eyes. It has millions and millions of them, and ears and bodies all spread over. What the hell would it ever even have to say to us? Why wouldn't it possibly be so alien that it understands we're intelligent, and we can infer that it is, but it manages transportation, and we manage our lives, and there's nothing really to exchange there. We want to think that it'll desperately want to talk to us, that it'll be just like we are. But I think that might be it certainly divorces itself from a lot of research about what's called embodied cognition, and how much of who we are is the very body that we inhabit. Well, that's a wildly different body.
I think we shouldn't think that, to echo Vivian's point, we shouldn't think that technologies will kind of be like us in any sense. In the early days when people wanted to fly, what people did, and I'm sure you've read about it or even seen paintings of it, people kind of stuck feathers onto their arms and flapped their arms quite a lot and weren't very successful at the flying thing. And so eventually we came up with a technical solution for flying, which is actually really different in many crucial respects from the way it happens in nature. And it's very, very likely to be the same with artificial intelligence, but both specifically and the systems that are there now do them differently from the way we do it, and in terms of general intelligence. Will it ever happen? I think it would be brave to rule it out, but happily it's a long way off.
I think we should try to understand what AGI is. I bet you if we interview 10 experts in the field, they will give you very different answers for what is artificial general intelligence. In general, they'll all say it's much smarter than whatever it is we have now. So I think part of the challenge is it's this, as soon as we start to understand something, we call it AI. And whatever we don't understand, that's AGI. So it's kind of a strange thing to describe. So I think we have algorithms, we'll continue to build algorithms to solve problems. I don't know, I don't think there's any evidence or imagined evidence of a version where we see this superhuman or supernatural or algorithm that can exhibit behavior where, often we're humanizing it, right? In the Go player, it's very easy to understand what it's doing in search space, but we go back and we're putting human-like qualities in it to see, it's thinking, it's stepping back, it's coming back, it's trying to trick you. When all it's really doing is searching through board configurations to figure out what's the right thing to do.
Yeah, what seems to me is interesting is whether you'd have to choose to build one. I mean, as you suggested, if you have a system that's running the global transport network, let's say, then I suppose what many people's fear is this science fiction fear that the thing is so intelligent running the transport network, it decides to run everything else as well of its own accord kind of thing. So but presumably, if we're talking about an AGI, if it is possible to build one, I suppose the question is, would we have to build it with the intention of building it? Or could it somehow emerge from a lower level complex system?
So I will say this, and it's actually a debate, very literally, that's going on in our field right now, which is, are the current technologies, specifically deep neural networks, enough to someday create AGI, or do we need to invent something completely new? I happen to be in the category that thinks we need something dramatically different. But I will, and part of my belief there is just maybe, hopefully, to put some concerns to rest, you can add more processors to our existing system. You can teach it more things. You can show it more newspapers. You can play it, the BBC, on a constant feed all the time, everything in the world. It will never wake up. It will never have an opinion about the issues of the day. It will never approve of Trump. It's supposed to be smarter than us, right? That sort of thing is not going to, in some sense, magically emerge. Your toaster is never going to wake up and threaten our very existence. But could we invent something new? Might that lead to this? Again, I see no theoretical reason why that's not possible. Right. It's just, I don't know what form it takes, and I don't know what infrastructure it takes.
Let me give you an example there. Like right now, we have computer systems that control, the basic public utility system, like water, electricity. And what if we had a different algorithm or computer come in and interfere and take down a node by, clogging it with traffic and such, or hacking the system? Now, would you call that AGI? That particular example I'm describing is very possible today. Basically, by building a system that has very, where points of failure are very concentrated, you can go attack those points of failure, and the system can go down, and you could now easily attribute it to AGI. But I think all it is computers that are optimized to build an objective function, and often we're programming them to do that.
But I do love, one of my favorite examples, though, of a system waking up is, and I'm blanking on his name, so if anyone's going to get the reference, pull it up, a Scottish writer who wrote a murder mystery. And it starts off purely as a murder mystery, and then it turns out what's happening, the thing that all these people have in common, is that they run spam. They're all a bunch of spammers. A spam bot training, getting more and more complex, and the constant cat and mouse game against spammers reaches sentience and realizes the way to stop the spam is to kill the people producing it in the first place. And that's what the police eventually figure out in the end. And, again, I don't think that anything like that is in the works.
Yeah, that was a fiction piece, right? Just making
Yes, it was pure fiction, but there are some things out there that are genuinely exciting that still don't require us to reach AGI, and some of them that are kind of fearful. It doesn't require artificial general intelligence to build autonomous weapons and program a little drone with a bunch of C4 packed into it to literally recognize my face and just zoom in as fast as it can and make a smart bullet, for lack of a better description. It doesn't require artificial general intelligence to build technologies that keep autocracies in power. Some of the very first system I ever worked on, 20 years ago, my introduction to machine learning was building real-time lie detection systems for the CIA. Now, that is very morally gray. Needless to say, it was incredibly cool. It just read people's facial expressions. And by the way, we were able to later use that same system, or I used those same algorithms. One case to build a system for Google Glass that could read people's facial expressions for autistic kids to learn how to read facial expressions. And another case to reunite orphan refugees with their extended family in refugee camps around the world. So it's not always so clear what's a good and a bad technology. But I will say some of those algorithms we developed 20 years ago, one, they're all in your iPhone 10. I mean, literally, that lab got bought as a startup by Apple. So we power all of your face stuff. So if you are, have you ever done the Animojis? So you can sort of smile and talk into your phone and it animates a cat. That cat is $50 million worth of CIA funding. All innovation in the end animates cats on phones. But at the same time, those algorithms are being used.
Do they do toasters as well?
I think someday we must surely have a smart toaster that's maybe just a little too smart. But the last is that those same algorithms are now being used in Western China in ways that I fundamentally disagree with. But this was just academic work. We published our algorithms, and now they're out there. And you can't always necessarily control these things. That's why setting norms are so important.
And just finally, just to go right back to the start, I mentioned the Turing test at the start. So an AGI, right? How do you define it? Is that something that passes the Turing test? Is that the definition, really? We perceive the thing to be intelligent. But if not, what is the definition?
So let's quickly go with, I think it would be really worthwhile for an ever so slightly deeper definition of the Turing test. So the Turing test is that there are sort of two black boxes, and I'm asking each of them questions, and I'm getting answers out of them. One's a person, one is an AI, and they're both trying to make me believe that they're a person. And then if I run this test over and over again, I am at chance at getting it right. A lot of people throw up in the news, hey, Twitter or Facebook just beat the Turing test because someone got on a phone and they heard a voice that sounded like a person, and so it beats. No. I have to be actively trying to trick. That was Turing's actual thing. And I'm not saying it's a magical test that's right or wrong, just it has a lot more nuance than people put to it. So if someone could violate the Turing test, where you're actively trying to figure it out, and over time, there's no difference. I'm not saying that's the magic ingredient for artificial general intelligence, but you have to admit you might just as well have a conversation with one of them versus another one. And there probably is some point at which the differences for specific tasks maybe don't matter that much.
Yeah. You're in agreement.
I just want to say one thing. You sit me next to an extraordinary woman who sorts out one weekend her son's diabetes and gets all the data. She unites orphans with their families in far-flung parts of the world. She helps autistic kids. And I agree with her from time to time, and you give me grief for agreeing with her. But there we are. I agree.
Maybe we should stop there. Should we stop there?
Well, you can have the last word if you'd like.
I think in that case of Turing test that you described, if somebody told me, here are the 6 things, or 7 or 8 or 9 or 10 things we're going to test the Turing test on, I could set up 10 DeepMinds. Each one's going to work very, very hard on one of those. And then I'm going to cycle between them so that the human on the other side is kind of working against a very competent machine. I could easily see a scenario where we'd pass the Turing test. So I still don't think that's qualitatively very different from where we are right now in terms of, so I'm not sure that definition of the Turing test is very relevant in defining AGI. I don't think we have a good one. I think that's what I started my premise with, which is I have a hard time understanding what human intelligence is, so it's really hard to think about what is AGI.
I think that's a very good place to end. So thank you to everyone that sent in questions. We've not been able to ask them all tonight, but we do encourage you to carry on the conversation. Keep asking questions. The Royal Society website's got a lot of background information on this area if you're interested. But for now, I'd just like to say, could we thank this superb panel?
Shall we?
Thank you very much.
Thanks.
Thank you. Good night. I'm going to ask it what it thought.